Students, now let us look at the dynamic programming technique for transportation planning. For example, for M modes and N cities, the number of solution alternatives would be M raised to the power N minus 1. So that would actually give us the total alternative solutions. That means we can have many solutions for a simple problem. A backward dynamic programming approach is proposed to solve the model. So dynamic programming, you might have learned it from your course in operations research. We have also discussed it in our previous sessions. That technique is very suitable and it is based on the backward induction method. In a dynamic programming model, we need to define stages, states, and decision variables. So in case of transportation system, each city would be treated as a stage in a dynamic programming procedure. And starting with city N-1, the transportation cost plus the transfer cost. So there will be two costs involved in it. The transportation cost as well as the transfer cost, because in intermodal transportation you might switch from one mode of transportation to another mode of transportation associated with continuing on the same mode or transferring it to different modes to go to the city N, and it would be given by this recursive function where Pn-1 would be of for any value of k and l. K and l would represent the city from to, and l will represent to a city to which you are taking your shipment, would be equal to TKLN-1. This is the transfer cost from the previous stage. Stage in this case would be our city, plus the shipment cost, that is shipment size Q, into the cost of transportation, that is C, from city N-1 to city N using some transportation mode L for all K. Here Pn-1 KL is the total cost of transportation associated with transferring from mode K to L at city N-1, and Q is the shipment size. Given the incoming mode K, the best choice of outgoing mode at city N-1 is M star. So M star is determined from the following expression: Pn-1 K M star, the best mode, outgoing mode M star, would be the minimum of all the Pn-1 KL for all K. So what does it mean? If you have 4 cities, then let's say you have to solve it from backward, that is you will solve it for city 4 first, and from city 4 you will first use the above expression to find the total cost, and then you will find for all the modes, तमाम मोड से क्या मुराद है, आप स्विचिंग देखेंगे K से L पे, यानी फॉर एग्जाम्पल यू हैव रेल टू एयर, फॉर एग्जाम्पल यू हैव रेल टू ट्रक, फॉर एग्जाम्पल यू हैव रेल टू सी. सारे मोड्स की आपने जो ट्रांसफर कॉस्ट और उसकी टोटल कॉस्ट, ट्रांसपोर्टेशन कॉस्ट है, वो कैलकुलेट करनी है. उसके बाद यू हैव टू सी द मिनिमम ऑफ इट. दिस इज what will actually give you the M star. Now from the last city stage, when you will move backward, so for cities 2 through N-2, that means all the intermediate stages, जितने भी cities दरमियान में होंगे, जैसे अगर हमने city 4 तक की बात की है तो city 4 last stage था, तो city 3 and city 2 would be the intermediate stages. Last city को नहीं लेना अभी. The corresponding equation to find the best transportation modes are as follows. तो वहां पर you have to modify the expressions. The expressions are given here. PIKL would be equal to the transfer cost, पहले की तरह ही मौजूद है, plus the total transportation cost जो QC I plus 1 L मोड के साथ मौजूद है, plus यहां पर additional क्या आपके पास मौजूद है, the cost that has incurred at the later stage. आप चूंकि backward solve कर रहे हैं तो वो solution आपके पास मौजूद होगा. And you can see that PI plus 1 with LM star is there. That is the minimum cost for all K. And of course, PIK R star here. R star would be the minimum one. वो वैसे ही है, minimum of PIKL for all Ks. Now comes the last stage, which is city 1. If you are using, if we have cities, we have called them cities or locations. The best mode to go to city 2 would be given by the following equation. P1 S star would be equal to minimum K QC, that is the total transportation cost for a city pair 1 to 2 for some mode K, plus P2 K R star. That means the best solution coming from city 2. So you will look at all the modes for city 1 and you will find the minimum of it. चूंकि minimum of K है, that means modes different होने के साथ QC and P2 का solution different होगा. So you have to look at the minimum one for it. Students, this was a basic technique of dynamic programming for transportation. Just keep it in mind, dynamic programming is a generic programming technique. And in transportation, we can actually formulate it in the way which we have done right now. We will take an example in our coming session to actually clarify the concept. Thank you.